Hello, Gen Chemers. Thank you for joining me today as we begin a conversation on Chapter 9, which is actually still going to really piggyback off of some concepts that we talked about in Chapter 8 with regards to bonding and orbitals. In this chapter, we're going to investigate theories of chemical bonding. And in this chapter, or in the MindTap modules, two different types of approaches are used to looking at chemical bonding. We are really going to focus just on one, valence bond theory, because that theory more closely matches with the Lewis dot structure concepts that we talked about in Chapter 8. Molecular orbital theory is incredibly powerful and incredibly accurate. It's not one that we're going to talk about in this course. It's one that's, I think, best to higher level chemistry classes. If you'd like to learn some more about molecular orbital theory, I'm going to have a bonus online associated with it. But this video, or this chapter, we're going to focus on this valence bond theory, which obviously is going to involve valence electrons, just like Lewis dot structures did. So when we think about bonding, specifically covalent bonding with regards to orbitals, we can think about that bonding occurring due to the sharing of valence electrons. We talked about that in Chapter 8 with Lewis dot structures. From an orbital mindset, we can think about those electrons being shared between two atoms when the orbitals that are involved with the atoms in the bond, when those orbitals overlap, so those electrons can be shared. That was shown in this potential energy diagram that we actually first introduced in Chapter 8, so this figure should look familiar to you. We originally used it to talk about that for covalent bonding to occur, that attraction between the nuclei and the electron has to be more than any repulsion that can occur between electrons or nuclei. But we can also use it to show that when electrons are being shared, that orbitals overlap. So for example, in the molecule H2, each hydrogen has one 1s orbital with one electron. There is some maximum, or there is some distance that it has an energy minimum where that covalent bond can occur, and that covalent bond occurs in the overlap region between the two orbitals. And so valence bond theory, which involves valence electrons, obviously predicts that atoms position themselves so that we get maximum amount of overlap of orbitals. Okay? And that overlap, that maximum overlap, gives minimum energy potential, as seen here, and also the strongest bonds, the strongest covalent bonds. So that is the crux of valence bond theory. And that also should bring up the question, okay, so we have these atomic orbitals that we are now thinking about as overlapping when forming covalent bonds. How does that change the orbital, or how does that change the orbitals that are involved? That's something that we're going to talk about shortly. But first, let's do an example where we can use Lewis dot structures to help us determine a valence bond description for a molecule. So let's say I was to have H2S. If I was to look at the bonds that are associated with that molecule, I would see that the bonds associated with the hydrogen and the sulfur occur because when I look at the atomic orbitals for the hydrogen and for the sulfur, those half-filled orbitals overlap, thereby sharing those electrons and forming the covalent bond. So those overlapping s and p orbitals predict the molecular and electronic geometry that we see for Lewis dot structures that we saw in chapter 8. So the take-home point from this particular example is that Lewis dot structures can help to be a shorthand notation for a valence bond description of a molecule. In the next video, we're going to talk about, while Lewis dot structures are helpful, sometimes they do not give a full picture. And when that happens, we can still think about covalent bonding as involving overlapping orbitals. But when those orbitals overlap, they create something called a hybrid orbital. And that is something that we will investigate in the next and in subsequent videos.